as part of this presentation. One of the first findings we had was that I'm not cut out for night work, so there we go. I'm just going to quickly run over our instrumentation plan and what we plan to take out of this project as part of our research for this work. So I guess if I back up, Professor Susan Tai, who most of you I'm sure are familiar with, is my advisor, and she was obviously very instrumental in all this work as well. So this work for the university's part was done within the CPATT group, so that's the Center for Pavement and Transportation Technology at the University of Waterloo. A bunch of the students that are part of that group are here today. And actually, a lot of our work was done by myself, Professor Tai, and Ching-Fan Liu helped quite a bit as well. And I guess before I get too far, our work on site this past week was wouldn't have been possible without a group of students that was there helping me and jumping at my every ask. So Ching-Fan, Andy, Raha, Zaid. I think I said everybody, but again, I'm a little loopy today. But thank you very much for your help, guys. Project team members, everyone's talked about that already. Stephen as well as Peter have talked about this, but our benefits are that the MTO's had good experience with Precast in the past. It's got good stress distribution, and you can get traffic on it immediately after placing it. So these are reasons why we're looking at Precast pavement. And again, this is just a nice little pictorial example of what we're doing. So we're milling partial depth of the asphalt and putting Precast concrete inlay panels in place of that asphalt. So it's novel, as Rico said, I think, when he was up here before. But what we'd like to do is make some research into these panels in terms of their constructability, so how easily they can be installed, how well they perform once they're in place, and how long they perform. So what sort of durability can we expect from this rehabilitation strategy? So for ourselves, our research hypotheses were that, first of all, this can serve as a long life rehab strategy. These will work is what we expect. User costs and life cycle costs can be reduced using this rehab strategy, and that's obviously in the situations where you're seeing a lot of shave and pave operations. So under certain circumstances, the user costs that are generally reduced by having just overnight installations can be reduced. And finally, that the performance of these panels is going to depend on the support conditions. So our objectives is to evaluate them in terms of their cost, their durability, and their constructability, develop some specs and models for future applications of this strategy if we find that it's worth putting forward, perform a life cycle cost analysis, and comment on the overall feasibility of this strategy for future rehabilitations. So our methodology was fairly simple in the broad view. We're going to monitor the construction activities. We're going to interview the contractor that actually is doing the work in this case. We have instrumentation in the field now, and then once we have all this information, we're going to synthesize our findings into some summary type documents. So we were out there all week, as I mentioned. I was taking notes diligently throughout the whole thing, measuring all the start times of each individual action that was taking place on site as best as I could, keeping note of the number of laborers, the machines, any issues or rework that were required. After the completion, so this week, I'm sitting down with our contractor and we're going to talk about some of the findings that they had based on what went down last week. So that's some cost information, but more comparisons to typical rehab strategies, any rework that was required, so what this was actually produced before the construction happened, but their contingencies that they had laid out for different things that went on, and their opinion of what the best option was. Based on that, we're going to do a bit of an analytic hierarchy process in order to get an idea of what support condition was best from the contractor's point of view. So each one of these things listed here will take the contractor's feelings and their data that they've collected and we'll rank each one and give each one a weighting based on both the MTO and the contractor's point of view, and come up with sort of a best option. We're also going to be analyzing the performance of the slabs. So they need to be durable and perform in order to be considered a feasible option. So we're going to be doing all sorts of site inspections, so condition surveys, noise testing, FWD testing the initial testing is scheduled for 2 weeks from last Thursday. Friction testing, and we have instrumentation under the slab. So we're using earth pressure cells, so load cells underneath our slabs, as well as moisture probes in order to gain some information on static loads on the cells. So these aren't going to be catching traffic loads, but we're going to be seeing curling pressures underneath from we're hoping to catch any curling pressures, but also will then, during site closures, install static surface traffic loads onto our panels that are instrumented, and get an idea of how that's affecting the layers underneath the slabs. So there's a moisture probe, and there's a pressure cell. So that's what we were installing in the field. So we're going to use this data as part of our finite element analysis that we're doing of these slabs, and their behavior is going to be used to develop this strategy further. So again, this has been touched on already. We had 6 different areas that we were installing our instrumentation, so that was 2 per support condition. This layout was what we had first expected. Due to a misplacement of my data logger, that was my fault. We had to actually move these 2 sensor arrays closer to the center of this project, but more or less things went as we had hoped. So in general, each installation involved two pressure cells, one at a slab edge, one in the center of the slab in the right wheel path, and then a moisture probe to monitor for the presence of moisture beneath the slabs. These are just typical dimensions that we used. This is the data logger was to be installed on the edge of site, as well as edge trenches to run cabling for our data logger system. And again, I'd like to point out how helpful Dufferin was in this whole process. They had a lot going on before I showed up, and still they spent a lot of time making sure that I was happy, which was nice. I don't know. It wouldn't have been possible without them. So this is typically what our work looked like on a given night. So I would lay out where our sensors were going, and then these areas would be saw cut by a member of the contractor's team. That asphalt within that saw cut area was then chipped out using pneumatic hammers. So we'd get an area somewhat like this. This is obviously a rough surface, but we installed some bedding material underneath that so that our sensors would be sitting on a uniform base. You can also see that a trench was dug out through the shoulders so that we could run our cabling out from where our sensors sat. The instrumentation was then installed in this orientation. So again, one was close to the edge of the slab, one was under the center of the slab, and then a moisture probe was installed sort of in the center of the instrumentation cluster. I don't know if you can see this, but this is again 2 members of the CPATT crew installing a moisture probe. Dufferin dug trenches, built a base for my data logger up here, and then ran PVC tubing throughout so we could instrument or collect the data from my instruments. And so I think that is a short summary of what we did, and if you have any questions about that or anything else that I could talk about, then that would be great. I'd also like to point out that this just happened, so in the coming months, and hopefully not too many months, we'll be putting out a lot of papers and work that we're doing based on the findings we come up with here. So thank you very much for your time, everybody.